So previously we talked about population standard deviations. Now we're going to talk about population proportions. So proportion is basically percentage, and the population proportion, the notation for that is pi, and for sample proportion, that's your p. And when we're dealing with proportions, our standard error or the adjusted standard deviation, this is the formula that we use. So your standard error for proportion is basically pi times 1 minus pi divided by n and then square root. And that's your standard error for population proportions. So again, if we were dealing with population standard deviation, then your standard error is your sigma divided by square root n. That's the first formula for standard error, and that's the formula for population standard deviations. When we're dealing with population proportions, the standard error is pi times 1 minus pi divided by n square root. So those are the two new formula that you need to know. The standard error for population standard deviations and the standard error for population proportions. So these are the two situations that we have. One is population standard deviation. That's the first situation. The second situation that we have is population proportions. Two situations. Example 2, if the true proportion of voters who supported proposition A is pi equals to 0.4, what is the probability that a sample size of 200 will yield our sample's proportion between 0.4 and 0.45? So our first step is drawing the diagram. So we have a bell shape here. This is our normal distributions. And then we have the population proportion, which is 0.4. That's your mean. That's why we have the 0.4 here. And then in this question, what we're looking for is the probability. This is what we're looking for. We're looking for the probability between 0.4 and 0.45. So this is like your x1 and x2. So 0.4 is like your x1. 0.45 is your x2. So that's why in the diagram we have 0.4 and then we're 0.45. And what we're looking for is the probability between 0.4 and 0.45. So what we're looking for is the area under the curve. We're looking for this area. And this is the probability of x between 0.4 and 0.45. And to find out the probability between two numbers, what we're going to do is we're going to first find the probability to the left of 0.45. We're going to find the probability to the left of 0.45. And then we're going to subtract that from the probability to the left of 0.4. And once we subtract these two numbers, that will give us the gap. And that gap is your probability between the two numbers. And that's what we're going to do right now. Once we understand the diagram, we know that we're looking for probability, so therefore we're going to use the formula norm.disk. We use the formula norm.disk because we're trying to find probability. If we're trying to find x, then we use norm.inv. And since we're looking for probability, so therefore we are using norm.disk. And they'll ask you for 4 variables. First variable is your x, second variable is your pi, which is your mean. Third variable is your standard error. Last variable is your cumulative. So the first variable, our x is 0.45. The reason x is 0.45 is because we're looking for x is less than or equal to 0.45. So that's our x. Second variable is your mean. Your mean is basically your population proportion, which is the 0.4. Third variable is your standard error or your adjusted standard deviation. The reason we're using adjusted standard deviation is because we're dealing with sample. Whenever we have a sample size, we have to use the adjusted standard deviations. So the formula for standard error for population proportion is pi times 1 minus pi divided by n square root. So therefore, we have the 0.4 times 1 minus 0.4 divided by 200 and then square root. And once you calculate that, you're going to get 0.03464. And that's your standard error for the proportion. And that's what we're going to put in for the standard error. And then last variable is always going to be true for cumulative. The reason it's true is because we're looking at continuous distribution. And for continuous distribution, we're including all the decimals. So therefore, we have to put true there. So I'll show you how to do that in Excel right now. So equal norm.disk, open bracket. You have your x is 0.45, comma, and then your mean is your population proportion, 0.4, comma, and then you have your standard error, which is 0.03464, and then comma true, then you close the bracket, you're going to get 0.9255. And that's the probability of x to the left of 0.45. So from a diagram perspective, we know that there are 92% to the left of x equals to 0.45. Next, we're going to calculate the probability of x less than or equal to 0.4, and we use the formula equal norm.disk. So our x is now 0.4. The reason x is 0.4 is because we're looking for the probability of x less than or equal to 0.4. Second variable is your mean. Mean is your population proportion. So mean is 0.4. And the standard error is the same. And then your last variable is your cumulative. Cumulative is true as well. It's the same. And then once you calculate that, and once you plug that into Excel, you're going to get the probability of x less than or equal to 0.4. That probability is going to be 0.5. So once we found out the two probability, then what we can do is subtract these two numbers, and then we're going to get 0.4255, which is the red area here. And that is the area of x between 0.4 and 0.45. And that's your answer for example 2.